Lesson 22, a review of numerical and algebraic expressions. So review, that sounds like it shouldn't be hard, right? Statements and sentences and conditional equations. Now, this whole lesson is pretty common sense. It's just adding in some vocabulary that might be new to you. So let's just jump right in and look at these things. Okay, I have just a single number. We have 6 plus 3. We have what we call all of these are expressions. Okay, it's an expression because do you see there is no equals sign and there's nothing on the other side. So they're not equations. They don't include an equal sign. So a numerical expression, they're all numerical expressions because they each consist of a meaningful, meaning they have operations that we could perform if we wanted to, arrangements of numerals and symbols that designate specific operations. Okay, operating in math means, arithmetic, plus, minus, multiplying and dividing. And if we look down to algebraic expressions, these all fit the definition of algebraic expressions. Because even though this has no variable in it, the definition of an algebraic expression is it describes numerical expressions and also expressions that include variables. So they include all of these, but also anything that has a variable in it. And a variable is a letter, right? Or an X, a Y, any letter that is representing any number. So what did we just learn about? Numerical expressions, algebraic expressions. Then we're going to talk about statements and sentences. Okay, again, we're going to look at English sentences and translate them into math sentences. So here are some English sentences. Let's look at letter A. The number of peaches equals the number of apples. Okay, the number of peaches does not equal the number of apples. The number of peaches is greater than the number of apples, and the number of peaches is less than the number of apples. Now, within these 4 sentences, we have an equation and we have inequalities. So when I say define the variable, we're going to translate these into math. Okay. So first, what we do is define the variables. Now, if you had me last year, I talked a lot about defining the variables, where you would start a sentence saying let. The book uses a variable or a letter with a subscript for their variables when we're doing story problems. I didn't learn it that way, but it makes sense to me. So they defined the variables and they said let n of p equal number of peaches. So that's how we define the variable. And let n of a equal the number of apples. So we define the variables so that we can use them in our math statements without having to write out the number of peaches. Now we can just replace it with n of p whenever we're talking about number of peaches and n of a when we're talking about number of apples. So take the English sentence A. The number of peaches equals the number of apples. So you would do this. Number of peaches equal number of apples. So we took a long sentence up here, or a sentence, I guess it's not long, and made it very short in math symbols. So this makes me happy. We took something super long and we shortened it up nice and tight right there. Now letter B, the statement is the number of peaches does not equal the number of apples. So I don't know if you're familiar with this symbol, but if it's not equal to, that's the not equal to sign. Number of apples. So if we read this in English, this says the number of peaches does not equal the number of apples, without writing all of that. So isn't that nice? Letter C, the number of peaches is greater than the number of apples. And then the last one would be the number of peaches is less than the number of apples. So we can write them all using very few symbols and variables. Now, I said one of these was an equation and the rest are inequalities. This is an equation because it equals. These are inequalities because they don't equal. This is the not equal to sign. This is an inequality and this is an inequality. So anytime we don't use equal, but it is a statement, not just an expression. An expression is just kind of sitting there, right? These have balances, something compared to something else, are inequalities. Okay. Let's look at this. An equation is an algebraic statement consisting of two algebraic expressions connected by an equal sign. So here we are, letter A. This is an equation. 4 equals 3 plus 1, and that actually is true. This one is an equation. 4 plus x is the same as or equals 2 plus 2 plus x, and that's true. And in the book, I was going to say, they want us to try these out to make sure they are true. So this one definitely is true because there's no variables, but let's say we're not sure about this one. So so they have us define, let x equal 7. And then let's test this equation. That would be 4 plus, remember I do parentheses where there's a letter. And let's check it out. That would be 11. And 2 plus 2 plus 7 is 11. So it's true. Okay, and we would prove this by going true. So once you get down to one side equals the other, we can say true, and this is how we test. All right, this one, letter C, is not true, is it? 4 does not equal 6, so it's false. It's still an equation, but it's a false equation. Okay, let's look at this one. Again, let x equal 7, and we'll test it out. 4 plus, and as you can probably guess, this is not true. 11 does not, and so I go like that, equal 13, so it's false. The equation was false. All right, what about this one? Well, let's see if we could figure out what this x equals, right? Well, let's look at, so that was false when we replaced it with the number 7. What if we replaced it with something else? Could we get this to work? Now the book goes through this in letter D. It doesn't matter what we try in here. They tried it with -3. I tried with 7. Either way, they got falses. Okay, so no matter what we replace x with, it's always going to be false. That means there exists no x. There's nothing that would make, if we add it to 4 and add it to 6, that would ever make that equal. But what about this one? Like I said, we could try 7, or let's try x equals -2. All right, let's let x equal -2. So it would look like this. Well, that equals that, and so that's false. But is there a variable, a number that would satisfy this equation, that would make it work? And you might look at it right here and be like, well, I know that 4 plus 4 is 8. So if we had x equal 4, then it would be true, and it would satisfy the equation. So x equals 4, and that works. So when we replace that, when we find something that works, we call it a root. So in this case, 4 is a root of this equation. A root just means an answer that solves it, an answer that works. We're gonna talk about that here soon. Well, here it is. Replacement values of the variable that turn the equation into a true equation, which is what happened here, are called solutions. which is an obvious term that you would use. It's a solution to the equation. Or roots, that might be a different vocabulary word. And you're going to use this a lot in second year algebra and calculus, and pre-calculus. And here it was again, that 4 is a root or a solution. X equals 4 is a root or a solution. Or the number 4 is a root or solution to this. Let's go ahead and do some examples. Does -2 or +5 satisfy the equation x squared equals -5x minus 6? Okay, so you're going to get ones like this in your homework. So how do we do that? Well, let's plug in these values and see if it works. So we're going to have two different things. I'll try -2 on this side. So we're going to, remember, put a parenthesis where that variable was, and then calculate both sides and see if it comes into a true statement. So -2 squared is +4, because this is squared, so it's -2 times -2 is +4, equals, and then that is 10 minus 6, and so that turns out to be a true statement, and so -2 does satisfy it. Let's try with +5 and see if we get that to work. And you see what is happening here? It is not true, is it? It's false. So when they ask if -2 and +5 satisfy the equation, what you would say in your answer that you would box is -2 is a solution or a root, but 5 is not. Okay, so that's how you're going to want to write your answers, to be very clear. Okay, don't leave it like this and assume that someone knows what that means. You're going to want to find, truly answer the question. Same here, -2 and +5 again, a root to this. So let's go ahead and try that again, but with a different equation, and see if this works. So I'm trying it with -2. And again, that's 4 plus 6 equal 10. And that's true. And let's try it with +5. And let's see if that works. That would be 25 minus 15 equal 10. And it sure does. So they both are true. And so how would you answer that? You would say both. You could even say both work, or both -2 and 5. And they asked if they're roots, so you would say are roots. And that's all you would have to have. All right. Oh, now you just have 2 practice problems for this. Not too bad. And let's go ahead and give that a try. You go ahead and do it, and then come back and check if you get stuck. Does -2 or 2 satisfy this equation? So I'm going to go ahead and try -2. Well, -2 and -2 make a -4, and that is false. Well, if I write false, I shouldn't write not equal to, because when I make that not equal to, then what I just said is actually true. So if we leave it like this, it's false. That's kind of how they want to do it. All right, the next, +2 we're going to try. And that does equal 0, and so that's true. So you would say 2 satisfies the equation, but -2 does not. Okay, it's good to be clear. Usually you don't have to write big sentences on answers, so if you ever have to, it's okay. It doesn't happen very often. All right, is -2 or -5 a root to those? That equation, And so obviously I'm trying -2 first. And that is true. And then let me try it with -5. It looks like that one works too. So I would just say, okay, I would even take this as a teacher. They both work. Or no, they asked if it's a root, so you could say they both work, because I'll know what you mean, and any other math person would know what you mean. But let's say they both are roots. Okay? That's it.